Good morning, everyone. And it's so great to be here in London again. I really enjoy. And thanks a lot to Sandro and his team for inviting me. I'm Alex. I'm from Romania. And I'd like to clarify one thing. So the community in Romania started almost 10 years ago, and we merged their Agile, Lean, and software craftsmanship. So we believe from the very beginning that these three things should be together. And about the first code retreat, one thing I'd like to say is very important is that it wouldn't have happened without Maria Diacono, who is our CEO and founder. So that's why we got to doing the first code retreat. She doesn't do that anymore, so I am most known for that, but that's how it started. So let's go to today's business because we have a lot to discuss and it will be an interesting journey. I'm going to talk about TDD as if you meant it. And this is our agenda for today. Just a quick discussion about TDD. I assume you know what it's about. And then we'll dive into this very special technique that allows us to kind of make it more deliberate, understand how the code evolves in a more deliberate way. And I'm going to show a very simple example. The only goal for this example is for you to get a grasp on on the basic techniques, how you can start, how you can work. It won't be a lot. So by the end, we'll have a very simple code, nothing too fancy. Don't expect a lot out of it. But we will learn a lot, I think. And then a few things about how we used this technique in teaching people, in community, and in actual work in production. So when I think about test-driven development, for me it's like you're brewing coffee. When you're brewing coffee, the drops of water go little by little through the coffee to extract the maximum flavor out of it. And what I try to do with test-driven development is to use the tests and to use the tension between tests and production code to extract the best design out of it. That's the metaphor I'm thinking about. And I won't go into red-green refactor. I assume you all know that. So for me, this is test-driven development. It's a process. And the goal of the process is to design software. And how we design the software by using this tension between tests and existing code and kind of going with it. Something that's commonly associated with test-driven development is emergent design. And people understand emergent design. Emergent has multiple meanings. And one common meaning is that it just appears. It appears out of somehow, okay? But emergency also has, or emergent, the word also has another meaning, which is in the context of system thinking, where the idea is, let's take, for example, your heart. Your heart is formed out of cells. Each cell has no idea how to contract or expand the heart. But together, they have an emergent property. And the emergent property is that your heart is beating. So when we talk about emergent design, what we are talking is an emergent property of a system. And the cells in our conversation here are programmer, test code, and production code. It's this whole system that works together to get design. So I will talk, I'm not very happy with the term pure TDD, but for the purpose of this talk, I will use it to mean when you are using tests, when you are using test-driven development, to obtain the design without any preconceived notions. It doesn't mean that you always need to do that. I don't want to shame anybody who's not doing pure TDD. That's not the reason. But I couldn't find a better name, so that's what I will use in the, for the purpose of the talk. And what I've noticed is that we rarely do that. In code retreats, where we do a lot of TDD experimenting, I notice one of the first things that people do when implementing Conway's game of life is to use an array. That's probably the first thing that most people are doing in their first code retreat session. And this is just a very quick jump towards the representation, towards a possible solution. And it's not the only solution. And then we want to try these techniques, not because we want to say your experience doesn't matter. Whatever you know about design until now is still very important. But what we want to do is to give you an opportunity to gather more experiences and more varied experiences with software design. So I think about TDD also as a way of exploring solution space. And that's something we will try to do here. So in this context, TDD, as if you meant it, is a set of constraints created by Keith Braithwaite. And I would say that force the practice of this style of TDD. And the set of constraints, there are various ways of stating them, but for the goal of this talk, I will focus on a simple explanation. And the idea is that you are not allowed to create basically any design element except by extracting out of a test. And that's the idea behind TDD as if you meant it. So a consequence of this is that what you do first is to write the production code inside the test code. And then you slowly refactor it out with an accent on slowly. Okay. It will feel slow. And so I have a simple example. I chose, because we needed a problem, I chose bank account kata. It's a fairly simple thing. I mean, we won't implement the whole thing anyway. So we'll just look at the techniques behind this. So because we needed a problem, I picked this one. And I will use Groovy and Spoke because I really like the two Groovy as a language and Spoke as a framework. It doesn't matter that much. You'll understand the code anyway. So, right. So it's time for our first test. And remember, we are not allowed to use any kind of variables. We are not allowed to use named things. We are not allowed to use functions. We can write a first test, but it has to be failing, right? Because it's TDD. And it has to be inside. It kind of merges the production and the test code in the same thing. So what would this test be? That's the one. And I know this sounds silly, but let's think about it for a minute, because anything we do to this test from now on will only make it worse, right? This is one of the few moments when you write perfect code. Yeah, it's so simple, it's so serene, it's very relaxing. I have a failing test, right? So then we start, because it's TDD as if you meant it, we start asking a few weird questions. And there will be a bunch of them. And the first weird question is, what is false, right? Because what we are trying to do is to extract the meaning out of that thing that we just wrote. And it's very interesting because this question seems, again, silly, but it's deeper than I imagined, because we are used with the logic definition of false. The logic definition of false is a truth value associated to an assertion. Like, London is in England. Yeah, that's true. We know that's true. Okay? But in programming, that's not what false is. In programming, you can write true, false to mean anything. It's not a real world thing, right? what it is in programming, it's either a constant or the result of an operation. And so with this in mind, we can make this test clearer by saying, what do we want from it? And we make it clearer in two ways. First, we write a name for it, right? Because before it was just some placeholder. And then, this is another very silly thing that we do, trying to refine the test. But we are still not implementing the production code. So once we do that, the next thing is how do we make this test pass? And of course, the simplest thing would be to have 5 equals 5, but that's not what we are trying to represent. What we are trying to represent is that we are making a deposit into an existing account. So that's not a good representation. And actually, the good implementation is this one. Right? I told you it will be slow. That's how it feels. But you see, at every step, you are figuring out more and more about the problem, about the solution, about all these things. And it's time to celebrate, of course, because we have a passing test. So now the next thing is, again, we are asking weird questions. Because now we can refactor, but we are not allowed to extract a method, for example. We are not allowed to extract a class. The only things we can do is to name things, basically, or to remove some duplication if there's any duplication in the code. So we start to ask weird question. What is 5 and what is 0? And these are kind of the repeated questions that we annoy people with at code retreats. We keep asking these. And we start naming them. So we have an initial account balance, an amount that we deposit, a final balance, and we also notice that we have an accidental duplication. This 5 is not the same as this 5. They look the same, but their meaning is different. So the intent is different. So now we have our first refactored test. And the problem with this approach is that you kind of get confused in what's the production code and what's the test code. Yeah, it's very easy to get confused. And that's why Adi, my brother, he did a lot of experiments with that, and he started to add comments to separate the production code inside the test. It's only, comments are bad, but it's only temporary, right? It's meant to be replaced with something else. So now we have a hidden duplication here, which is in the name. We have a few notions already that we are using. And you can see it's fairly strange because we only wrote like 5 lines of code and we already have 5 different notions involved in this thing. And we have a duplication of notion. We said empty account, but this means something specific. So we could remove that and go to this. We just change the name, right? And it starts to get clearer. So now the next step is to triangulate. And triangulation is a way of pushing the solution forward. The idea is to fix all the values and only change one of them at a time. And it's a core TDD practice that's been done. I think especially classicist style is very common. And when we talk why it's called triangulation, triangulation in the real world means finding the coordinates, identifying one point on Earth, right? You need 3 coordinates to do that. What is triangulation in this case? Well, the thing is we are actually navigating a solution space. And you can imagine that as being a multi-dimensional space. what we want to do is to fix most of the coordinates and navigate only on one of them and kind of advance on that. Right, so what can we triangulate on? These are a few ideas. And that's kind of how I think even when I do the faster TDD cycles, figure out kind of what could be the next test. And we could change the initial balance, the deposit amount, we could add currency, because right now we don't have currency, it's just numbers. We could have a count. And let's pick the simplest one. And then the next question is what values are interesting, which are the values that would advance our solution. And to do that, we apply one technique that's called equivalence partitioning in testing. I call it value sampling before I knew there was a term in testing, so we have this. I'm contributing to the confusion of creating new terms. So, and the idea is to find the intervals of values that are equivalent in terms of the final behavior, and then pick at least one value from each interval in order to advance the solution. So, what are interesting values in this case? Negative values, 0, positive, maybe a minimum, maybe a maximum, right? I know for a fact that Bill Gates has a special accountant because the national systems in, I don't know, financial services in US couldn't handle his fortunes, so then they had to make some special software for it. So, you know, minimum and maximum could help with that. And then we only did the integers, but, you know, that's not how it's going on. Right, so we ask a bunch of questions. Typically, you would go with this to business analysts or whatever, figure out the answers. And then going back to triangulation, which are interesting values, where there's a minimum, there's a maximum, and there's any value within this interval. And then there are some invalid values. I just picked them for the goal of this exercise. It will probably be different in a real bank, right? So now we have a new test, and again we expect false. Okay, that's our perfect test once again. And the next thing is we are talking about 1. We clarify it, we make it pass, and again we can celebrate, right? It works. We have 2 passing tests. And now we can refactor and we see the same thing again. There's some structure that is repeating and is trying to get out of it. But, so we have duplication between tests, but it's not yet the time to refactor. We apply this rule of thumb that's called rule of 3. And of course, in this case, it's ludicrous, okay? But many times when we see duplication in just 2 places, it may just happen that it's accidental and that we need to wait a bit longer to see it the 3rd time before we can actually say, oh, these pieces of code will actually change at the same time. So we try to apply this rule. It's a rule of thumb. So sometimes you only see it 2 times, sometimes you see it 5 times, right? It's not a law. And so we write another test. Yeah, again, our perfect test. And we go through the steps of extracting thing. And then we have an interesting question. Again, what is this? What is 1 billion in this case? And the answer is it has a name. So how about naming it properly? Right? So now we have the notion of a max balance. And this starts, I mean, now if you think about triangulation, we could think that maybe an account in euro has a different maximum balance than an an account in dollars or in RON or whatever. Or maybe these things are even configured depending on who has the account, or I don't know. There may be many rules that are trying to get out of there. So now what we can do, because we have duplication 3 times kind of similar code, and we have 2 options. We can remove duplication between tests while keeping only the tests, or you can remove duplication from the production code, which is now inside the tests. And this is how you write in Spock a data-driven test, where it's basically the same test, but it's run 3 times. Now, the problem with this one, it doesn't feel that it advances you towards a solution. I haven't yet extracted any production code. And I'll come back to that because I think there's something interesting here. But let's go with the flow. So instead of doing that, we extract the production code. We can now see 3 times the same method, so we can extract it. And we have a method, we called it. This is already a design step, right? You named it. You named the method somehow. It has parameters, it returns something. Okay, so let's reflect a bit. What's going on here? Not much, right? Not a lot of code, but in doing all these things, although it feels slow, we named things. We understood a bit better the domain. We navigated a bit around. We learned about business rules. It's not everything now in code, but it's kind of guiding us. And we have the simplest solution. There's no simpler solution right now for this specific problem that is defined by the tests. So, and we can also see, and this is the most important thing, because remember what we are trying to do. We are trying to show how the code evolves. We started from a constant, we turned it into a variable, and then we ended up with methods. And this went out in a very natural way. At every step, I made a decision that made sense, naming things, removing duplication, and so on. But we ended up with a method that does something. So let's look into the future. Presumably, a code, something like that, will end up with this after a few cycles, where we test for max balance, minimum balance, stuff like that. And we'll presumably also implement a withdraw method that kind of does the same thing, but on the reverse. So we have these 2 things. And now there's a very interesting choice before us. We can go functional, or we can go object-oriented. Because until now, what we have are 2 pure functions. And we can keep them pure functions, or we can go towards a more object-oriented approach. And this would be a functional solution, right? It's something that where you kind of change the method. Well, let's say almost functional, right? So that people don't hate me. But it kind of goes that way. Or we can go this way and say deposit and withdraw, they have a kind of cohesion, maybe. So how about moving them somewhere? How do we call that thing? Maybe account. I don't know. Or maybe we can go this way and say we have some kind of transactions that apply on an account, and then we do something like that. And of course, in order to get there, you have to do more cycles. So it's not, I'm just skipping a bit to show you the juicy parts. And so this was, again, a very interesting thing for me, because one thing I learned is I always had this friction in my mind between functional and object-oriented. I know, for me, design is about structuring the code in order to serve a certain purpose. How you structure the code So functional programming has a lot of advantages for various reasons. But there should be an equivalence. I always thought there should be an equivalence between the structuring the code in a functional way and in an object-oriented way. And it turns out that there is one, because a class is nothing more than a set of cohesive, partially applied, pure functions. And what do we mean by that? If we look at these two, and the first is the object-oriented, and this is the functional, there's only one difference, this, which probably here is a parameter inside the class. So the equivalence between these two is that this is partially applied. That's what partial application means. By creating a constructor where you pass in the initial balance, is the same thing as saying, let's fix initial balance to 0 and get a function that only gets an amount out of it. So that was interesting for me. And there's always the case that I noticed this happening a lot when you do TDD as if you meant it. Only it takes about 1.5 hours to get there. So that's kind of the moment when you realize, oh, so we can go that way or the other way. Right. And now let's get back. Remember that I was talking about data-driven tests and how they feel they don't advance our production code. I think there's something interesting here. I'm not yet sure that it's useful in all situations, but one thing I started trying and practicing was to take this, and I noticed that what this tells me really is something like this, that is valid no matter what currency you use, no matter what type of account it is, no matter who owns that account. So that sounds a lot like a property from property-based testing. What we are saying, we are making a statement about the system that it's valid for a lot of different cases. And I know it's not exactly a property, right? But my intuition is that if we keep doing this and keep refining it, we might end up with a set of properties. And how would you implement this? There's a library, Spock Genesis. It's really great. And you can use it like this. And what this says is anything between the minimum accepted deposit and the maximum balance, any amount, take 500 of those. I don't care what they are, but this property should stay valid, no matter what happens there. And you can make this, now it's an integer, but you can make this to be a currency, or a real amount that also has currency. You can make it more specific. So that was, again, an interesting thing for me that I got out of TDD as if you meant it. So let's think back again. As you see from this practice, it didn't seem much, but it started to understand better about, alternatives, possible solutions to our problem. And we also figured out alternatives about how we could go around testing. And another interesting thing is our options were open for a very long time. You keep your options open, and you can still keep them open. You don't have to pick immediately functional object-oriented. You can keep extracting more and more functions, adding transactions, adding balance sheets, and all these things. And only at the end, look at the functions, or later on, look at the functions and say, these are cohesive. Let's put them in a class. These are cohesive. Let's put them in another class. It still feels slow, right? I mean, as I said, usually when you do that, you have to do it for at least 2 hours to get something actually out of it, something that's interesting. So now, I hope at least I showed you that you can learn a lot by being very deliberate about these steps. Because the whole goal of this exercise is to look carefully at every decision that you make, question it, and figure out which are the alternatives. We rarely think as software developers about all the possible solutions or about more than one solution. We kind of have the solutions that we saw in the past and they have built into our intuition. And we tend to go with those because those are the fastest, those are the easiest. And our brain is lazy. It doesn't want to think. What it wants is to go directly to another, to, make it work. Make it work. And that's why this process feels painful, because it's all about expanding your views and looking at other ways of doing it. So if you want to practice it, I would advise you to either go to a community event, or if you want, you can do it by yourself in 45-minute sessions, but continue where you left off, so kind of build upon your code from the past. And think about how the design evolves. Think about the changes that happen there. Which design elements appear as you do this? And this is very important. Try to make every decision as deliberate as possible. Question it and say, so is this what I can do now? Which are other options? What are other 3 options of doing this? Of course, until now it's not that much, right? But you will see as you go, if you take a problem like this and you keep working on it, there will be some points where you have more possible decision. And again, the goal of it is to figure out, to gather other experiences, to see where the code can go. Now, we also applied it in production, and I know this sounds a bit strange because it feels slow, right? So when do you have the time to do that? And how can you do that, since in production there are a lot of complex things? And what we actually did is, there's this show that maybe you've seen, and it's now hit Netflix, and I binge watched it because it was really fun. And I noticed one interesting thing about Mythbusters. Whenever they try to do an experiment, a large-scale experiment, something that works, and they did some very huge things, what they start doing is a small-scale experiment. They never jump into, make this work at real scale. What they do first is they do a really low-scale experiment, and then keep scaling up until they get to the point where they are happy. They think, okay, we have removed all the risks, we have the right designs, now we can make the experiment. And so what we've done is to separate small problems. And one example is we had a control, a JavaScript UI control. Well, basically, you could add multiple text boxes, and you could have one or more, and then keep adding and filling them, and you needed to have validation, and you needed to have all these things, and then they should be submitted to the server in the right way, okay? And it was done using jQuery, so no fancy Angular React things, just the bare bones. So, and we started doing this as TDD as if you meant it by really starting to write a small test class in our code. and then writing the implementation little by little. And once we had it, then just plug it into the existing thing. But it was a very small, separate problem and with clear boundaries, right? It was very obvious how you would call it from outside. There was no problem there. So this is how we've used it. And one of the interesting things about this is our code base is fairly well organized, and I like it, but it still has grown in time. And sometimes I feel like it's big. It's not as big as the code bases you work on, probably, but I feel it's big. And having this ability of going small is really liberating. You feel like you are, again, starting kind of from scratch. It's really nice. You are working on it. And then you also have something that fits into and adds value to the product. So, just to close, the reality is if you practice a bit, the whole initial steps, they don't take long. It becomes very quick if you know keyboard shortcuts, refactoring, your IDE, and all that. Because if you have to write all the code by hand, then yeah, it will be extremely slow. Right? So you need to know that. It helped me personally to understand more about functional programming and about design and to be more deliberate. And as I said, it's very nice to work on a small, clean piece of code, even when you have, again, clean code in the rest of the product, but it still maybe is big. So there's one code that I really like. As developers, we often complain about constraints. What we say is, only if we had more time, only if we had better tools, if we had more money, if we would get so good results, such good designs. And I think that's the wrong way of putting it, because in reality, constraints are part of our designs. And it's a mistake to confuse constraints with compromises. And I found this quote by Charles Eames, who was a designer and architect. He designed chairs and made movies, and he did a lot of different things. And that's what he said: I've never been forced to accept compromises, but I have always willingly accepted constraints. And constraints are part of our work, and if you embrace them, you'll also learn more about how design works. Now, if you want to learn more about it, my brother started doing a series of codecasts. And if you go to his blog, you'll find them. They are fairly entertaining, as far as I've heard. I couldn't watch them yet. We work in the same office, but it rarely happens. So I advise you to take a look at those. And I've been Alex. It's been a real pleasure to be here. And what I want to leave you with is what we say as Mosaic works: think, design, and work smart. Thank you.
Hello, I just wanted to ask you if really in a production code you go with pure TDD, because I see advantages of that when you're doing katas, so you evolve your brain, the way of thinking. But then when you go with the production code, when you want to be pragmatic and reach something in a limited time, then basically if you do that pure TDD, then I guess you repeat lots of the steps you've done with the other projects, for instance. So that's where the experience comes in, right?
Yeah, so, well, I wanted to say that thank you for the question, because it allows me to clarify something. We don't use this approach for all production code, right? But we found it's very useful, especially in those cases where you don't know enough about the problem or enough about the solution. And in that case, that was a particular case where many things could go wrong. The example that I gave with the control and so on. Many things could go wrong. We knew the behavior quite well. And also we weren't very, we know JavaScript, but we didn't know back then to a level that allowed us to do it like very quickly and so on. So in contexts like this, where you are missing a lot of pieces, it's very useful to go step by step because it allows you to learn at the same time and still produce something by the end. But I would never advocate for you to forget everything you know and to keep doing those things. No. It's one technique. It's good to have it in your toolbox and take it out whenever it applies, right?
Any more questions? Okay.
Does TDD, as if you meant it, constrain you to use the same language for the production code and the tests? The reason I'm asking that is I might be joining a team that uses Spot Groovy for tests and Java for the production code. And I'm wondering if there's any way you could make TDD as if you meant it work in that case.
Well, so in this specific case, because we use Groovy, what I know is that you can basically write Java code inside Groovy. So you can start, but you have to be disciplined into using types and all those things. And then basically the same code, you extract it out as a Java class and it will work. So you can do this, but it's in this particular case. It's a property of Groovy that it works like this.
Cool, thanks. I'm going to give it a shot.
Okay.
Okay, I think we're done. Thank you very much.
Thank you.
Thank you.